Hi, here we're gonna show the DIY air blower. You need an old broken vacuum cleaner for that, or a thrown away one. It would be nice to make sure it at least turns around so that the brushes of the turbine are not broken or anything. That would be nice. Anyway, we're gonna ditch all this stuff and we're interested in the turbine. It's just in here. We wanna open it up and see how it looks. So here we open it up. It's the lid. There's also a few torque screws, small ones. Here's the turbine. Remove this cloth for it, and now take it out of there. Let's have a look. Yeah, it has some holes here that needs to be plugged from the inside, but we can do that. This metal thingy will slide right off. Rubbers we don't need anymore, although they could be come in handy later. Let's have a look. The wires. What I like to do most of the time is to reuse this wire. What I'm gonna do is I'm gonna cut this wire at 1 meter or whatever, and then make it on this one. Cut it here. So we have an extension cord now, and a retractable extension cord. We can make plug on a female plug and an outlet plug on here, and then we can still put it on and off with this thing and have the controller, which comes from here, to regulate the output. It's especially interesting for an angle grinder. Anyway, modify the turbine first. Here I'm reassembling the vacuum cleaner again. I put the wire, cut off the stacker, put the wire through the hose, through this thing, with the connector, and a slit in this part, so we can still mount the original buttons and frames back to its place. Be back in a while. Alright, to make the system works with the hose, we cut off both ends, so we only have the tube left. We cut 3 PVC pieces, could be the same height, at least 80 millimeters high, I would recommend, or 100. Then you can use 2 of those to burn them around, burn and glue them around this tube. And we have one that can fit as a suction port in here. We have to heat it up and we spread it out, glue everything in the end. But first we're gonna make this one, and then we're gonna bend this strip for around here. What we need for the output is one of those things, working with attach valve and more stuff along the way. First this one, we want to have this one right there with a hole cut in it. So we're gonna bend this small strip around the tube like this, like that. We roll it around, we hold it with pliers, or you don't, whatever you want, and then it should be made that it fits around here. Be right back. This is how the strip looks. It could have been all the way parallel, but it's not that necessary. It's just for holding the output tube in place, because you spot weld it here and then you slide it over and you glue everything together. So you burn them around each other, and then you pull this one out, cover it with glue, and make the rest around the edge, and then tie a little piece of duct tape and heat it up too, so it shrinks around there. That will do perfectly fine. So this is how the extension cord for the gas should look like after you do this. I placed aluminium tape around it because I ran out of duct tape. So be it. Now we do the same for the air blower. Now, turbine is oiled. Put some extra W40 in there. Cut the hole out to match with the 1/2 inch tube. And now I'm gonna weld this thing on it and make it around there. One moment. Now we glue all those things shut so we don't have any leakage. We place this thing around here like this. We have to cut some of this strip off. So let's cut that, weld it, put it on, glue everything, and see how it works. And here we are. All glued, taped. Now I'm going to put it back and let's see how it starts up. And here we are. Pretty strong. 40 volts from the DC to DC converter. It uses now less than 1 amp. 820 and 130. If we stop it, it goes down 1/10 of an amp or so. And this is a vacuum hose now. This is very little electricity. I think this will do for the gasifier perfectly fine. This amount of power. This is the same turbine as the other one, but this one is new. So I hope it will be performing even better, or around the same. $32 watts. Maybe less. Oh yeah, if you want to reduce the electric consumption of it by a lot, by a half of something, or at least 40% less, at least in my experience, then do the 4 screws, pull the thing out. Underneath the bearing there's a thingy in there, which is it's a kind of washer, but it goes up and down and stuff. You kind of poke it out in some way. Wait up. But you can see it, right? The up and down going. That takes the bearings under quite a bit of tension, which is necessary for the 220 volt and well, I don't know, 15,000 RPM run stuff. You need the bearings to do that probably, but not now. It consumes more power. I managed to get it loose now and out. So you can see it's a wavy spring tension washer. We don't want that. Let's put it back together. Now it's back together. We're gonna hammer the bearing a little bit more inwards. Or we hammer the shaft a little bit inwards, then we align the bearing inside. Because I want this to have a little play sideways, just a minuscule amount. Now I'm testing the new ventilator made from the old vacuum cleaner system. Now this one must be given 50 volts to achieve the same pressure as the other one, and it consumes about 0.9 amps now, because if I let it go, this thing is about 0.15, 0.2. So let's set between 1.1 and 1.2. So here it's so it's about 90, I think, 85. Yeah, I mean, just You see what I mean, the differences? It's not correct. This one is correct. Now this one is correct now. Oh, minus. Yeah, 0.8. 0.8 is perfectly fine. 0.9 also. That means that it's less than 50 watts, which is perfectly acceptable for 10 kilowatts. No, 11. This one is the GZ8, which means it can do 8 cubic meters an hour with this specific insert. Anyway, you can also use a double stage that will run less quick, like this one, made in the same way. From a double stage, there's two things in here. You can do the same thing with the other one, but you have one extra shell, one extra turbine to deal with. And I use a little more electricity in the end to achieve the same goal. Because what we need is about 25 centimeters peak pressure. Sometimes 30 if you want to push it really bad. And most of the time around 20 to 25 across the nozzle. That's the rule of thumb now. To make enough pressure drop for the Venturi effect, which enhances the quality by a factor 10 or 20 or something. Makes all the difference in between the single nozzle and the multi nozzle and then the swirl nozzle. There's all this extra benefits in this process, and then the process will be better and better every time you improve it. You can do it anyway. You will get reasonably clean gas from a single nozzle Venturi combustor as well. It's not so bad, but only if you want to go as far as you can by having zero tar. That means not even pink, that means just deep blue and a little white sometimes. That's I believe hydrogen and CO. Anyway, now we can use this small one as a suction blower for the startup, because this thing is too big for on this heat exchanger. Moment. I'm gonna go for the small compressor as I has, because this one makes almost 30 centimeters of pressure for the same electricity as the other one does. 23.5 centimeters, almost 24, which is perfect what we need. But this one is using 20 to 25% less electricity, because it needs only 40 volts to do the same pressure. So you can have something in between there.